environmental and cost-effective. However, their resistance to degradation makes them persist in environment for a long time. As a result, they can accumulate in ecosystem and contribute to serious environmental problems such as pollution. Therefore, it is important for us to reconsider their environmental impact and explore more sustainable alternatives.
Let's talk about the key concept of this topic. Firstly, I will give the definition of synthetic polymer. Synthetic polymer are polymer that are synthesized in a laboratory for commercial production. It is usually derived from petroleum oil through polymerization. So, what is polymerization? Polymerization is basically a chemical process which links small molecules, called monomers, into a long chain with a high molecular weight known as polymer. There are three types of synthetic polymer. Firstly are thermoplastic, thermoset, and elastomer. These polymers have a very distinct characteristic that able to differentiate with each other. Firstly are thermoplastic are soft and moldable when heated and hardened upon cooling. The common type from this category include polyethylene (PE), PVC, and polypropylene (PP). Thermoset is a polymer that hardens permanently after being molded and cannot be reshaped. It decomposes upon reheating. Examples of these polymers are such as epoxy resin, phenolic, and polyurethane. And lastly are elastomer. Elastomer is a polymer that have high elasticity and viscosity. Examples of these polymers are such as natural rubber, styrene butadiene rubber or SBR, and silicone rubber.
Okay, so now let's continue to the real life application of the synthetic polymers. So the first one we have the medicine and daily life and also the industry. So for the medicine we have the biodegradable structure that being used in surgery. Polymers like polyglycolic acid and also polylactic acid are used for internal stitches that do not need to be manually removed. Okay, so the chemistry concept behind this biodegradable structure is hydrolysis and also the ester linkage. These polymers are joined by ester bond and the water molecule in our body tissue cause hydrolysis to be occurred. The water molecule will attack the ester bond and break the long polymer chain. So this will allowing the structure to be dissolved once the wound would be healed. So the second part is the daily life. So we use the non-stick cookware. The coating on non-stick pan is made of polytetrafluoroethylene (PTFE) or commonly known as Teflon. So the chemistry concept behind this non-stick cookware is the electronegativity and also the carbon-fluorine bond strength. So fluorine is actually the most electronegative element, and the carbon-fluorine bond is incredibly strong and also stable. Furthermore, the London dispersion force between the Teflon and the substance, for example food, are extremely weak and resulting in a very low coefficient of friction. So this will cause the food or for example eggs don't stick to the pan. So the last part is the industry. We choose the high performance tire for the real life application. Automotive tires are made of synthetic rubbers like styrene butadiene rubber (SBR), which must withstand immense mechanical stress and heat. So the chemistry concept behind the high performance tire, such as the Formula 1 tire, is cross-linking and also vulcanization. So raw synthetic rubber consists a long sliding polymer chain that are soft and flow when heated. During manufacturing, sulfur is added in a process called vulcanization. This creates covalent sulfur bridges between the individual polymer chains. So the outcome is this cross-link prevent the chain from sliding past each other permanently. Instead, they can stretch and then snap back into place, giving the tire its elasticity and high thermal stability, which is essential for safety at high speed.
For the group analysis, we talked about two things, that is the advantages and limitation, the future trends, and lastly the impacts on health and environment. Firstly, for the advantages and limitation, we compared it in terms of durability and cost. For the durability, synthetic polymers have long lifespan, with resistance to chemicals, water, and moisture. However, they do not break down in natural recycling system. Next, for cost, synthetic polymers are extremely cheap for mass production. However, they have heavy carbon footprints due to the production being tied to non-renewable source. Next, for the future trends, we talked about bio-based polymers, use of supercritical carbon dioxide as solvent, and cellulose nanofibers. Bio-based polymers such as PLA and PHAs are being scaled to replace traditional plastic. This is because recent studies have shown that PLA has high impacts on water eutrophication and has significantly lower greenhouse gas emission compared to traditional plastic. Next, the use of supercritical carbon dioxide as a solvent during manufacturing process will help to eliminate the need of toxic organic used during the manufacturing process. Lastly, cellulose nanofibers are being developed for its viability for industrial use. This is because by incorporating cellulose into biopolymers, we can enhance the mechanical strength of the synthetic polymers, which makes it viable for industrial use and also 3D printing. Firstly, for the impacts on environment and health. So for the impacts on environment, microplastic factors can lead to biotoxicity in marine life. This is because synthetic polymers over time will turn into microplastic that will absorb toxins in the water and get transported into the food chain. And then the degradation of synthetic polymers will release dioxin and other greenhouse gases that can over time lead to the climate change. Next, for the impact on health, microplastic accumulation in organs can increase the risk of cardiovascular disease, while additives like BPA that is added into synthetic polymers can mimic hormones such as estrogen that can lead to reproduction disorders.
So, to summarize, synthetic polymers are man-made materials produced through polymerization consisting of long chains of repeating monomers. They can be classified in thermoplastic, thermosets, and elastomers based on their properties. In real life, these polymers are widely used in many fields. For example, in medicine, biodegradables such as like PGA and PLA are used because they can dissolve in the body. In daily life, non-stick cookware use PTFE, which prevents food from sticking. In industry, synthetic rubber such as SBR is used in tires due to its strength and heat resistance. However, despite these advantages, most synthetic polymers are non-biodegradable and can cause serious environmental problems like pollution and microplastics. Therefore, it is important for us to consider environmental impact by reducing usage, improving recycling, and developing biodegradable alternatives to ensure a more sustainable future.